Hey everyone, Catherine here. If you watched the previous video, we're going to continue from there. If you didn't see it, f of x equals x over x plus 1, g of x equals 1 over x. The first thing we're asked to do is find the domain of f. Now I wrote this in here, I'm going to need more room than that, but that's okay. Let's get started. So f of, I like to rewrite it, is going to be f of x. Now that means that this is f of x. Well, what's f of x? F of x is x over x plus 1. Okay? But what is f of x over x plus 1? I know it's crazy to say. But what we're going to do is I'm going to rewrite my function, but I'm going to put a parentheses everywhere I have a variable. Okay? Now I'm going to put this in for each variable. So I'm going to have x over x plus 1, x over x plus 1, and we're going to have, let me write it here, x over x plus 1 all over x over x plus 1 plus 1. Yuck! Yeah, that's crazy. And we're going to need to simplify it. Now that's pretty cool. It's not too bad, but that means that we have to find a common denominator. So what I'm going to do is I'm going to rewrite it here on my scratch paper, just the denominator. X over x plus 1 plus 1. Now we need a common denominator. Remember, 1 is just 1 over 1. So I have x plus 1 and I have 1. So our common denominator is going to just be x plus 1. When I look at my first fraction, I already have x plus 1 in the denominator. So I don't need to do anything with that one. But with the next one, I do need x plus 1 in the denominator. 1 times x plus 1 is just itself, x plus 1. But remember, if I do it to the denominator, I have to do it to the numerator. Now this is the fun part, right? We have a common denominator. We are going to collect like terms in the numerator. But first let's write it. X plus 1 all over x plus 1. Great. Now we're going to collect some like terms here. X plus x is 2x plus 1 over x plus 1. Now that's just the denominator. That's just this piece here. All right. We're going to rewrite the top. X over x plus 1 all over. Now we're going to replace it. Yikes. We are going to replace it with this guy. 2x plus 1 all over x plus 1. Now when we divide fractions, we change it to a multiplication and flip the second fraction. And that's what we're going to do. We keep the first one, x over x plus 1, make it a multiplication, and then flip the second fraction, x plus 1 over 2x plus 1. All right. Now we're going to just multiply straight across. But we're not actually going to multiply. We're just going to write it. It's kind of a weird thing to say. Because we need to figure out the domain. And we don't want to have, 2x squared and all this stuff. Because we're going to have to factor it again. X times x plus 1 all over x plus 1 times 2x plus 1. Okay. Now what's really cool about this one, I'm not sure if you see it, but we have x plus 1 over x plus 1. So those are going to cancel. Yay. And that's going to leave us with x over 2x plus 1. Now the question comes, well, what is the denominator? All right. We decided that this equals 2x plus 1 over... Okay, I had to go to another piece of paper because I'm just running out of scratch paper. All I did was just rewrite f of x equals x over x plus 1, and that's the only one we have to worry about right now because we're finding f of f. Well, we found f of x, and that is x over 2x plus 1. Now we have to figure out the domain. Now I always forget to do this. I have to look at the original domain first. We should say original function, original domain, let's see, original function domain. That's terrible English, but original domain of the function, or original function. You get what I'm saying. And the original f of x is x over x plus 1. Now, once again, we ask ourselves, what can we not have in the denominator? Well, we can't have 0, right? It cannot equal 0. So let's write it out. X plus 1 cannot equal 0. Some of you will say, hey, well, x is negative 1, right? That's right. But if you don't see it, let's just do a little algebra. We're going to subtract 1 from both sides. So x cannot equal negative 1. So that's our first problem we have with the domain. The second problem we have is way up here. Now remember, we still cannot have a 0 in the denominator. We don't have anything weird in the numerator or the top like a square root, so we don't have to worry about that guy. And we're not canceling anything. I'm going to do exactly what I did here. I know that this cannot equal 0. So I'm going to have 2x plus 1 cannot equal 0. Now let's do some algebra, all right? I'm going to subtract 1 from both sides. Remember, whatever you do to one side of the not equal sign, you do to the other side. We'll have 2x cannot equal negative 1. But now we have 2 times x. And what's the opposite of multiplying? Dividing. Yep. So we are going to divide by whatever is hooked to the variable. And in this case, we have a 2. So we're going to divide by 2 on both sides. So x cannot equal negative 1/2. All right, we have all the restraints. I'm going to put in negative 1, negative 1/2. I'm going to put a 0 in there just so we kind of see where we are on the number line. So x cannot equal negative 1, so I'm going to put a open circle there. X cannot equal negative 1/2. I'm going to put an open circle there. But it could be anything else, right? It could be anything here, anything all the way that way. All right, what's that going to look like then? Where am I going to, or what's happening on this side? Well, we have negative infinity. Okay. Now remember, anytime we talk about infinity, we have a parentheses. Now we're going from negative infinity to negative 1, but we don't include negative 1, so we have a parentheses. Then, which is the same thing as union, we're going from negative 1. Okay, once again, we're not including negative 1, so we have a parentheses, comma. Where are we going to now? Well, we're going to negative 1/2. Now we're not including negative 1/2, so we put a parentheses. But we're not done yet. We also have to include our union. We have to include this stuff. So we start at negative 1/2. Now we can't include it, so that's why we have a parentheses, comma, and we go all the way to infinity. And there you go. A little side note, some people have a hard time writing infinity. Just think of writing an 8, or if you have to, just write a sideways 8. That works too. Or just practice. It's kind of fun. Okay, that is how you find f of f. Now we have to find g of g. Oh my goodness. Okay, I came to the other half of the piece of paper we started on, and we need to find the domain of GOG of x. And g of x is 1 over x. What I like to do is rewrite it, g of x, okay? Now, what's g of x? Well, it's 1 over x. So we'll have g of 1 over x. Well, what's g? G, I don't know. What is g? Well, it's 1 over x. So it's 1 over, and we put a parentheses. Now, everywhere we have an x, we're going to put 1 over x. So that's really what GOG is. We do need to simplify it. We are dividing fractions. It might not look like it, but on the numerator at the top, we really have a 1 over 1. And to do that, we're going to keep the first fraction. I'm going to keep it as 1 over 1. We're going to multiply, and then we're going to flip. Pardon me, this is 1 over 1. Let's rewrite it. 1 over 1 times, we're going to flip the second fraction, x over 1. We're going to multiply straight across. So 1 times x is x, 1 times 1 is 1. So it's going to turn out to be just x. Cool. But now we have to figure out what is our domain. I always have to remember to go back to the original. So g of x is 1 over x. And now once again, we ask ourselves, what can x not be? Well, the denominator cannot be 0. Or I should have said, what can the denominator not be? 0. That means x cannot equal 0. Now let's look at when we did GOG, what did we get for an answer? Well, we got this one. And that's the same thing as saying x over 1. And we ask ourselves again, what can the denominator not be? Well, it can't be 0. Since we don't have a variable in here, we don't have to worry about it, right? No worries. So that means the only problem we have is at 0. I'm going to make my number line. And I'm going to put 0 right in the middle. Since we cannot have 0, I'm going to put an open circle. Now what we can have is everything over here, everything over here. So let's write our interval notation. What's happening on the left? Well, I have negative infinity. You can write negative sideways 8 if you like, comma. Now we're going to go to 0, but we can't include 0. So we're going to have 0 in a parentheses. And, or union, we're going to start at 0, but not including 0. So that's why we have a parentheses to infinity. And we just did all of it. Pretty cool.